Hello, my name's Dermot O'Shea and welcome to Tauglass USA. We're here in our San Diego engineering facility. So normally here we do antenna design and testing on a daily basis. So we can do any passive or active device antenna and RF testing. For example, return loss, antenna efficiency and over-the-air testing like TRP and TIS. So we're going to mount some of our 4G LTE antennas on and in a vehicle and drive test them on the live 4G LTE network here in San Diego. The first antennas that we're going to test is our popular Pantheon series. So these all have 2x2 LTE and GPS. There are also 4-in-1 or 5-in-1 options with 2x2 Wi-Fi or 915 or Wi-Fi added. These have a very thick thread and nut for secure mounting onto the roof of a commercial vehicle or a remote asset. They do also come with shorter thread and nut options, for example mounting on the trunk lid of a police car. For evaluation purposes, our customers use this mag base, which is what we're going to do in this case, so you don't have to drill a hole in the roof because the antenna may not permanently live there. So we can mount these antennas on these mag mount bases, which you'll see when we go out to the vehicle itself. The first antenna we're going to compare it to is an internally mounted external stream antenna series. So it's got 2x2 LTE and GPS. We're going to install this under the seat of the vehicle because that will give us maybe a similar install environment to what a lot of customers do in this case, which is put on the windscreen of a vehicle or actually put under the dashboard. We're also going to test our shockwave antennas. These are NMO mount or N-type mounted antennas that also go on top of the remote asset or the vehicle. You've probably seen these style of antennas on police cars and emergency service vehicles. We'll use our mag mount bases today. They come with an option for a mag mount base, again because it's not a permanent install. We're also going to evaluate our Apex series, which are our popular terminal antennas. Again, they'll be mounted on a mag mount base. Normally these are used directly on routers and gateways as a terminal antenna. And then finally, we're also going to evaluate our embedded antennas. So these two ceramic antennas are called the Gemini series, a very effective way to implement LTE MIMO solution inside your box on your main PCB. In this case, we've made a prototype PCB with some of our equipment here, and we have cabled out to SMA connectors so we can test them on the router itself. So the routers we're going to use today are 2x2 LTE, our 4G MIMO and GPS routers. And thanks to one of our partners, Sierra Wireless, who've given us two Airlink GX440 routers. So we're going to do one antenna configuration versus another on the live network. Thanks to one of our other partners, DCS, for lighting these two units up on the Verizon 4G LTE network. We were testing this earlier in our chamber, which we can hook up to a base station simulator and simulate the actual live network in the perfect RF environment, that being the anechoic chamber. The perfect RF environment means it doesn't let any signals in or out, so you have no interference, and the microwave absorber cones don't allow any reflections, so we can get a pure measurement of the actual antenna performance. We're going to do a real life drive test. So we're going to do it at certain scenic or historic points in San Diego, those being Torrey Pines, Mount Soledad, Fiesta Island, Petco Park, Qualcomm Stadium and East County, which is a more remote area. So we're trying to get an urban, remote and scenic area that we can do different test points on of the actual real life LTE network. So San Diego is always a good place to do a drive test because, as usual, the sun is shining. So let's go. So our test vehicle that we're going to use is a Dodge Ram pickup truck. We connect the cables down through the window and we've two cellular antenna cables for 2x2 LTE MIMO and one antenna cable for GPS. We then connect a serial port cable to our laptop computer, and the green Ethernet cable for internet connection so we can measure the speed on the network via the laptop. We bring power to the laptop via an AC adapter which is plugged into the cigarette lighter. You can see that the signal lights quickly go from orange to green and we're ready to go on the LTE network. For the adhesive mount antenna, we've placed it in the glove compartment, and for the onboard embedded antennas, we've put them under the seat of the vehicle. This is so that we can get as close as possible to a real life customer installation scenario. So here we are leaving the office. You can see in the first test we're doing the Pantheon versus our Shockwaves. So before we go into the numbers, here's how the metrics we used work and what they mean. First we have reference signal received power, RSRP. In this case, RSRP measures the coverage of the LTE device on the downlink. This is the quality of signal coming from the cell site, generally a cell tower. RSRP serves two main functions. Firstly, it's used to determine which cell site in the surrounding area would offer the best downlink for the device in use. Secondly, RSRP can be used to ascertain the QoS, or quality of service, that the device should expect to get. The next metric is reference signal received quality, or RSRQ. RSRQ is used to determine the best cell site for LTE radio connection at certain geographic locations. Like RSRP, RSRQ can be used as a criteria for initial cell selection or handover. It is an important indicator of your cellular received signal strength. Finally, we have signal to noise ratio, or SINR. SINR in this case is used to measure the quality of LTE wireless connections as the energy of the signal fades. This fading can be the result of distance from the cell site, but background noise and other devices simultaneously connecting are also causes of this. So our first drive test location is Torrey Pines, home of the 2008 US Open, and then we moved on to Mount Soledad, the National Veterans Memorial. It's also a great location because you get good elevation. Also, you can enjoy some great views of the city, Miramar Air Force Base. Also some nice views of the Pacific Ocean, Black Beach, La Jolla Shores. And obviously we've got some great test results here. First, the RSRQ is at minus 12 dBm, which is okay. Ideally we want between minus 9 and minus 12 dBm for an acceptable user experience. Next up, the RSRP at minus 88 dBm is also okay. Acceptable RSRP quality ranges between minus 75 to minus 95 dBm. Finally, the SINR is at 2.4, which is actually fair. 0 and below is where this gets unacceptable. Fiesta Island is a place that we often do drive tests on. It's one of our GPS test locations because it has no obstructions, nothing can block your view of the sky, and similar for cellular. It's also close to downtown, so we can kind of measure non-urban environment and urban environment when we move to this downtown location. So here are the results from Fiesta Island, which are actually very similar to Mount Soledad and just a tiny little bit better. So here we are outside Petco Park, home of the San Diego Padres. This is a very good urban environment reference test. We've the convention centre right across the road, gas lamp district just around the corner, skyscrapers, office buildings all around us, freeways close by. So in an area like this, you're going to have many devices transmitting and receiving via LTE on the network. Then we move east out to Qualcomm Stadium, home of the San Diego Chargers, the NFL team from San Diego. After that, we continue to move east to a rural area, believe it or not, known as East County. So that's as rural as you'll get in the San Diego area. It's basically a desert area. So East County has very good RSRP and RSRQ readings, but the SINR dropped to 0. We actually expected this to happen in our rural environment test, and the technical reasons for this are detailed in the test report that accompanies this video. So we find ourselves back at our US headquarters after a great day out around San Diego. We have a written report up on our website alongside this video with a more in-depth look at the numbers and locations, as well as some superb pictures taken by our photographer. We did also do some comparison testing against some competitor antennas. That's confidential information and can be released under NDA. If you have any questions about the products shown or on the testing itself, please don't hesitate to contact us. All our contact details are on our website at taoglass.com. I hope you enjoyed the video and thanks for watching.